Hello everyone, NASA recently had its ignition event where it changed its plans rather dramatically, and we have a lot to talk about. I'm not going to get into the politics of it in these videos, I certainly could, but let's set that aside for now and just talk about it in, let's say, Kerbal Space Program terms. In other words, the space logistics and whether this is a good way of getting space missions done. And I'm going to begin with Lunar Gateway. And the reason I'm beginning with it is because it's probably the most maligned part of the original plan. And one of the reasons is what we see here. It's pretty high up from the moon, right? Now, this isn't a real rectilinear halo orbit. In Kerbal Space Program without Principia, you can't really put it into a rectilinear halo orbit. It is in something like that. And for those who don't know, it's basically an orbit that's sort of like this, okay? It's polar around the moon. There's the moon down there. And it gets close to the moon at the South Pole and then really high up over the moon at the North Pole. Or it could be vice versa. And what we see here is, yeah, it's pretty high up over the Earth and pretty high up over the moon. And people pointed out, somewhat rightly, that that makes it rather inconvenient. It means that the landers have to do a lot of work going from the lunar surface up to Lunar Gateway. It saves Orion from having, or any other spacecraft that you're sending from Earth, some effort, because that spacecraft does not have to get into low lunar orbit. So how did we get this? Well, I don't know how we got this exactly, but I can tell you the logic of it as far as I'm concerned. And the logic of it is that if we could get fuel from the surface of the moon, if we could drill for water, convert it to hydrogen and oxygen, and then fuel our landers that way, that means that they have more ability to get further along than something coming all the way from Earth. So we would rather that the thing we sent from Earth stay lighter, and then we can just maximize the landers because we're getting the fuel for landers from the moon. And that's a lot easier. Getting anything off of Earth is really hard because Earth is big. Well, relatively big. And it's also quite distant. So you put a space station here, and you can get your spaceship from the Earth to the space station relatively easily. The amount it takes to capture around the moon is on the order of about 200 to 300 meters per second, and then you can depart to Earth with another 200 to 300 meters per second. This is a trivial amount of delta V. 200 to 300 meters per second either way, so a total of 400 to 600 meters per second would be about what you would have in low Earth orbit for low Earth orbit missions. We then have Orion, which actually has about 1,300 meters per second, and Orion can not only get itself to this orbit, but could also tug one of these modules into orbit as well. That was one of the ideas when launching these, when these were supposed to be launched on SLS. Orion would help get them, into orbit or position them. So that's why Orion has the delta V that it has. How much does it take to get into low orbit around the moon? About 800 to 900 meters per second, and another 800 to 900 to get back. So you talk about 1600 to 1800 in that case. So that's a lot more than it takes to get it to Lunar Gateway. So if you're concerned about how much effort it takes to get stuff from Earth to here, then this is minimizing that, as long as you can drill for fuel from the moon. Which means that Lunar Gateway was sort of ahead of its time. People malign it, but the problem with it isn't actually that having a station around the moon is a bad idea, or having a station in this orbit around the moon is a bad idea. The problem is we don't have the resource production on the moon to make this make sense. So people do malign it for the wrong reason. It's actually ahead of its time is the problem. And so maybe shelving it would be a good idea, but shelving it isn't exactly what NASA has in mind. So let's take a look at what NASA seems to have in mind. So this is from the Ignition presentation. There's the artist concept of a nuclear mission to the moon, not a full-on nuclear thermal mission. And so we've got nuclear power in space to Mars and beyond. And we've got this spacecraft that's supposed to go to Mars. And, they give I'm certainly in favor of nuclear things, as we know. But this spacecraft is peculiar. What we have in the back is the power and propulsion elements, the PPE, now with 3 of the ion thrusters instead of just 2. So the normal PPE that was for Gateway that we saw just now had 2 ion thrusters rated at about 14 kilowatts. This would have 3, so that means a total of 42 kilowatts. But you notice the little stubby solar panels instead of grand, huge solar panels. And that is because they have now a nuclear reactor on this side. And they've tried to keep it safe from all the electronics in particular. We need it distant from the electronics. And they say the nuclear reactor provides more than 20 kilonewtons. Yes, I keep saying kilonewtons. Kilowatts. Oh, well, it better be more than 20 kilowatts. It better be 42 kilowatts at least, so that it can power the 3 ion thrusters. Otherwise, why do you have 3? Why do you have 3 instead of 2? Well, let's go back to Kerbal Space Program. Let's activate our 2. And what we see here is a stage time of 3 years, 150 days, and a stage delta V of 10,000. Well, 3 years is a long time, and that is because this was made to do station keeping around the moon. It's supposed to keep the station in its prescribed orbit around the moon. It doesn't need a whole lot of thrust for that. We see like 1 Newton. Okay? But we want it to last a long time, so 3 years. It wouldn't be just doing 3 years, of course. It would be using its ion thrusters intermittently or at low power for a much longer period of time in theory. And then it has this awesome delta V, which certainly can handle all the station keeping and all that business. And now, what is it going to be doing for Mars then? Well, it's presumably going to be capturing itself around Mars. Now, Mars capture takes 2,000 meters per second. You can help that out along the way. But any way you look at it, getting that kind of delta V is going to take this a long time. Like, let's say half a year. Let's just say half a year for now. It's actually more than that. And I'm saying half a year because that's how long it takes to actually get to Mars. So the Mars transit is going to be at least half a year, maybe 9 months. And you're going to need to do more than half a year of burning in order to eventually capture around Mars to match Mars's orbit. So we've got a thrust limit problem here, which is why they've got 3 ion thrusters on the version in their presentation. They probably need even more than that, I would suggest, but so then you need more solar panelry if you were going to use solar panels. But if you were just going to use solar panels, there's really no purpose in sending it to Mars. It's not the best thing to use to send a payload over to Mars. If you had a lot more thrust, it would be nice, but it's meant to be for station keeping around the moon. It's not meant for that purpose. So that's why it's so peculiar. And we go back. And what you could do is, all right, you got 3 ion thrusters. Mars has half the solar input that Earth has. So what you could do is put 6 times the solar panels. Now that's a lot, but if you're going to have, like a piston like this anyway, you could easily see that you could fit that, and that would be a lot cheaper than having the nuclear reactor. Not to mention less controversial and less expensive. So we have this nuclear reactor. And then the purpose is to test a nuclear reactor, because there's no purpose in sending this to Mars other than to test this nuclear reactor. The nuclear reactor says it's more than 20 kilowatts electric, which is not enough to drive 3 of these. And then it's got a 1-year operational lifetime, which is not long enough to really verify that it could do substantial missions. The whole point of a nuclear reactor is for it to last quite a long time, at least 3 to 5 years. So we would like it to be operational for longer than that. But maybe this is one of those cases with JPL where they always say it's got to be operational for a certain amount of time, and then it ends up lasting 10 to 100 times longer than that. So, we could have that situation. But this is ending up quite expensive. We've got a nuclear reactor with nuclear stuff. We've got the titanium radiators. And we've got ion engines, which are also not cheap. And the xenon for the ion engines, which is also not cheap. And the payload that they're planning to send over there are just 3 of the Ingenuity helicopters. So, well, it's an interesting test of technology, which I've always said that NASA should be doing. But I don't know. Something about the numbers don't check out, and I don't think they have the money for it. So they in their presentation have committed to quite a lot of things. So they're going to do the Skyfall Mars helicopter thing, and with that setup, deploy these 3 helicopters. But of course, you could do this with a much smaller setup, and certainly not a nuclear reactor. So the purpose is to test a nuclear reactor. We don't have the nuclear reactor, though. So this is a test of a system we do not have. We have smaller ones that were in work, kilopower and all that. But we haven't deployed any of those into space. Instead of sending a small one, we're trying to send a new big one that we haven't developed yet, which will cost a lot of money. And I don't know what kind of funding they're going to get for this. Right now, it's a whole bunch of pretty pictures, which always makes me worried. Constellation was the same way. A whole lot of pretty pictures, not much funding. And we've got the promise of a moon base. We've got promise of nuclear reactors in space, and I forget what else. Oh, yes, we've got a whole lot of commercial applications. We've got the lunar commercial. We've got trying to support the commercial stuff in low Earth orbit, even though they're not really sure they want a low Earth orbit commercial station. Anyway, let's set those aside for now. Focus on the gateway situation. So now they're repurposing the power and propulsion element to this mission. And, well, at least that saves it, At least that saves it. And it'll be testing some interesting things. But up to 48 kilowatts advanced electric propulsion and a 20 kilowatt reactor. And they say greater than. And I'm going, well, it better be at least twice that much. So my position on Lunar Gateway is that it's ahead of its time until we can set up in situ resource utilization on the moon, getting the water, converting it to hydrogen and oxygen, and having a lander that can use that, and demonstrating all of that. So on the one hand, setting it aside is possibly reasonable, though the way people malign it is a little bit unreasonable. They have an irrational hatred of this orbit that largely comes from the fact that they do not understand it, and I sympathize. I did not understand it. So, I did not understand why it should be in this orbit. But I have, in the auspices of Kerbal Space Program, conducted missions out here and placed my stations into orbits like this and seen how it all works out. And so now I understand, okay, well, it can work out. It can work out and be useful to do it like this instead of bringing it all the way down to lunar surface. By the way, there is an issue of mass concentrations on the surface of the moon, in that if you try to keep a mission in a low lunar orbit, it doesn't like to stay there, and you need a lot more effort to keep something there. So having a low lunar orbit station is a lot harder than having one up here. You're going to need to expend a lot more propellant keeping it in the right place. There are frozen orbits on the moon. These are the ones that avoid the mass concentrations of the moon, and there are certain inclinations where those orbits are more stable than the other orbits. But Still, this is probably a lower effort thing in terms of keeping a station there. The question is whether you want a station around the moon to begin with. If you want a station around the moon, this is a good location to put it. If you don't want a station around the moon, well, then that's a different story. And now we're going with a moon base. And everybody would say that, well, a moon base sounds a lot better and more stable than a base that is in orbit around the moon, station. So, and I would agree. I would rather have a base on the surface of the moon than a station around the moon. But eventually, it would be good to have both. However, the question is, do we have anything ready to be a base on the moon? And do we have the money for a base on the moon? These are two questions that I am troubled by because I don't think we do. And we will see. So this has been a discussion, just Lunar Gateway. And if it is a straight up trade and saying that, oh, well, we'll get rid of this and we're going to get a base on the moon, well, that would be great. If we take a look at how much the moon base is going to cost, it's going to be way more than the cost of this Lunar Gateway. Before I go, I'll broach another subject that comes up when it comes to Lunar Gateway as an argument against it, and that's that Starship could be a space station, and it's certainly roomy. The problem with Starship is that it's too roomy. It's got too much mass. It's a huge dry mass, which you're going to have to refuel, and you're not going to be able to keep it in position with little ion thrusters, which are very efficient, like you can with this. Instead, you're going to be needing to run RCS, which is very inefficient, sending over the fuel for that because that's going to be running on methane, and methane can't be produced on the moon. So at the very worst, what you would want is something that runs on hydrogen and oxygen, not methane. And you can get that on the moon and then resupply the station like that. Yeah, I wouldn't think that Starship would be the best sort of station because of its sheer size, the fact that its orbit is going to be constantly perturbed and it's going to have to station keep. And it can't really use ion thrusters for that unless they were really, really huge ones that we don't have right now. So that's about the size of that. So I don't think Starship, even though they tried to make it a drop-in replacement for everything, I don't think Starship is a particularly good station in any situation. So, with that being said, that's my take on Gateway. Alas, nobody's going to listen to me anyway. I didn't like it that much in the first place, but I could see where it could eventually have been a useful thing, but probably not the most useful thing right now. Things had to happen on the surface of the moon to make this make sense. So with that, thank you for watching. I hope you enjoyed this video. If you did, please do press like. If you have any comments or suggestions, please leave them in the comment section below, and I'll see you next time.